Hello everyone, we are from the group 1 and in this video we will present the material for finite state machine and behavior trees, where this test is a test given by a robotics control course lecturer. Before that, introduce the names of the teams members from group 1, with me, Nurul Indah Mawaddah, as the moderator in this group, and three my friends. There are Muhammad Revalba Ginggang, Eka Septian Edrianto, and Fadhil Irfan Hibatullah. Alright, let's go straight to the material that will be explained by me and my group of friends.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about part D of finite state machine definition. Finite state machine (FSM) is a control system design methodology that describes the behavior or working principle of the system using the following three things: state, event, and action. At some point in a significant period of time, the system will be in on of the active state. The system can switch or transition to another state if it gets certain input or event, either from external event or component in the system itself. This state transition is generally also accompanied by action performed by the system when responding to input that occur. The action taken can be simple action or involve a series of relative complex process.
Yes, this is for the chart infinite state machine. Like the picture, the diagram show an finite state machine with two state and two input, and four different output action as shown in the figure. When the system start up, the system will transition to state 0. In this state, the system will generate action 1 if input event 0 occurs, whereas if event 1 occurs, then action 2 will be executed. Then the next system transition to state 1.
Okay, for the example of finite state machines is typically used to organize and represent execute flow, which is useful for implementation AI in games. Finite state machine implementation begin with its position and the transition it will have. Image the following finite state machines representing the brain of an ant bring home a leaf. The starting point is the fin leaf position, which will remain active until the ant fin the leaf. When that happens, the current state is shifted to go home, which remains active until the ants return. When the ants finally arrive home, the active states become fine leaf, so the ant repeats its journey. If the active state search for a leaf and the mouse cursor approach the end. Then there is a transition to the run stage. While the stage is active, the end will run away from the mouse cursor. When the cursor is no longer authorized, there is a transition back to the leaf-seeking stage. Since there is a transition connection, find leaf and run away, the end will always run away from the mouse cursor. As it's approaching while the end is looking for the leaf, it won't happen if the active position is home. In this case, the end will walk home fearless, only transitioning on the leaf stage it found when it arrived home. For the advance and disadvance of finite state machine. A. Advanced finite state machine has several advances, including 1. Simply so easy to implement. 2. Predictable response. 3. Like computing. 4. Relative flexible. 5. It is an old AI method that can be used on various systems. 6. Easy to transfer from abstract to program code. This advantage, in addition to have many advances, finite state machine also has several weaknesses, including 1. Due to its predictable nature, the implementation of the game is not preferred. 2. Implementation on large systems is more difficult because setup and maintenance are complex. 3. Should only be used on systems where the property of the system can be decomposed into states. 4. The conditions for state transition are constant.
Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Revalba Ginggang. I'm from Batam State Polytechnic, Department of Electrical Engineering and Study Program Robotic Engineering. And in here I will continue presentation before from Nurul, Indah, Mawaddah. I will explain about behavior tree. Behavior tree. What is behavior tree? So behavior tree is a mathematical model of plan execution used in computer science, robotic control system, and video game. They are discrete switching between a finite set of tasks in modular fashion. Their strength comes from their ability to create very complex tasks composed of simple tasks without worrying how the simple tasks are implemented. Behavior tree presents some similarities to hierarchical state machine, with the key difference that the main building block of a behavior is touch rather than a state. And behavior tree are a combination of many different AI techniques like hierarchical state machines, scheduling, planning, and execution. Behavior tree or BT is a way to structure the switching between different tasks in autonomous agent, such as a robot or a virtual entity in computer game. BT or behavior tree is a very efficient way to creating complex systems that are both modular and reactive. These properties are crucial in many applications, which has led to the spread of behavior tree from computer game programming to many branches of AI and robotics. Behavior tree terminology. Behavior tree terminology is execute in discrete update step known as ticks. When behavior tree is ticked, usually at some specific rate, is shall not recursively tick based on how the tree is constructed. After a not tick, it's written a status to its parent, which can be success, failure, or running, like this sequence. Example: the sequence is if you want if you want to open the door, and if the human detect sensor is squint is like success, and we and if we human don't if sensor cannot detect human is like failure, like the like that's one. This example from robot searching using behavior tree, and our robot likely operate in environment with multiple location, and the idea is to look in all possible location until we find the object of interest. This can be done by introducing a root level fallback node and repeating the above behavior for each location in some specific order. This algorithm from search robot in any location. Finally, suppose that instead of looking for a single object, we want to consider several objects, let's say apple and orange. This use case composing condition can be done with parallel node as shown below. Maybe you can see this location like, and if we accept either an apple or an orange or condition, then we success if one not return success. If we require both an apple and orange and condition, then we success if both not return success. If we care about the order of object, you must find an apple before finding an orange. Then this could be done with a sequence node instead. As you can see, like this paragraph, not paragraph, like this diagram. Okay. If I make mistake word, I'm sorry, and thank you for watching this video. Assalamualaikum warahmatullahi wabarakatuh.
Well, that was an explanation of the material brought by my friends. And here, there is a conclusion from the material that finite state machines are useful for implementing AI logic in the games. This engine can be easily represented using graphics, which allow developers to see the big picture, tweak, and optimize the final result. And behavior tree is a mathematical model in the form of a tree created to represent the behavior of a programmed entity. Behavior tree is something that is very fundamental in the game development. The behavior tree is similar to the finite state machine. It's just that unlike the finite state machine, which contains states, the behavior tree contains a collection of instructions and commands that must be executed by developer, because the use of the behavior tree is easy for human to understand, so that the error rate is minimized. And so many presentation that we convey, more or less, we are apologies. Thank you.